A single one of these colossal machines can generate enough electricity to power thousands of homes for an entire year. Its enormous blades can reach speeds of more than 185 miles per hour. But how does the force of the wind actually become electricity? In this video, we are going to discover how a wind turbine works to generate energy. Let's find out. Wind turbines are so massive that their blades can be more than 330 feet long and sweep an area larger than several football fields. If just one of those blades were placed upright, it would be taller than many 30-story buildings. But despite their gigantic size, they are built with ultralight and extremely strong materials, such as fiberglass and carbon fiber, capable of withstanding years of exposure to storms, heavy rain, and extreme changes in temperature. And although the rotor may appear to spin slowly, the tips of the blades can reach speeds of more than 185 miles per hour, faster than many high-speed trains. But moving structures of this size is an enormous engineering challenge. Each blade can weigh more than 50 tons and must withstand powerful forces created by the wind. They are designed to flex, just like the wings of an airplane during flight. When operating at full capacity, a wind turbine can generate between 3,000 and 7,000 kilowatts of electricity every hour. That amount of energy can be enough to supply approximately 3,000 to 5,000 homes for an entire year. When the wind reaches a turbine, it hits its gigantic blades. At first, it may look like the blades are simply being pushed by the air, but the process is much more complex than that. The blades have an aerodynamic design very similar to airplane wings. Their carefully calculated shape causes the air to move faster on one side than the other, creating a pressure difference that generates a powerful lifting force. This force is what truly makes the rotor begin to move. The three blades are connected to a massive central piece called the hub. When the wind blows, the rotor begins to turn slowly. And even though the tips of the blades can reach speeds of more than 185 miles per hour, the complete rotor turns at a surprisingly slow rhythm, usually between 10 and 20 revolutions per minute. But even at that seemingly modest speed, the amount of energy being captured is enormous. The movement of the rotor is transferred through a strong main shaft into the nacelle, the large structure located at the top of the tower. This is the true operations center of the turbine. Inside it are some of the most complex and valuable components in the entire installation. It contains electronic systems, safety brakes, intelligent sensors, hydraulic mechanisms, and the electric generator. The mechanical energy created by the rotor first passes through an enormous gearbox, one of the most impressive and complex components in the entire turbine. This gigantic set of high-strength steel gears works in a way similar to a car transmission, but on a colossal scale. Its job is to solve one of the biggest challenges of wind energy. Although the rotor captures a huge amount of energy, it spins too slowly for the electric generator to work efficiently. Electric generators need much higher speeds to produce large amounts of electricity, and that is where the gearbox comes into action. Inside it, several sets of gears work in perfect synchronization to gradually increase the rotational speed. A rotor moving at 15 revolutions per minute can come out of the gearbox spinning at around 1,800 revolutions per minute, which is about 120 times faster. This increase allows the generator to reach the ideal conditions to produce electricity in a stable and efficient way. The forces this mechanism must withstand are extraordinary. Each gear has to transmit enormous amounts of power while enduring loads caused by the constant fluctuations of the wind. The gearbox can handle thousands of horsepower continuously for years. For that reason, the gears are made from special steels that go through heat treatments to greatly increase their hardness and resistance to wear. On top of that, the entire system is submerged in hundreds of liters of lubricating oil, which reduces friction, disperses heat, and extends the life of the components. And this is where the true technological magic happens. Inside the generator are large magnets and copper coils. When the magnets spin around the coils, they create a changing magnetic field that forces the electrons inside the copper to move. That movement of electrons is exactly what electric current is. It is the same physical principle discovered by Michael Faraday almost 2 centuries ago, and it is still the foundation of nearly all electricity production in the world today. But modern turbines do not simply spin and produce power. They are equipped with a sophisticated network of sensors, capable of constantly analyzing wind speed, wind direction, ambient temperature, structural vibrations, and even the presence of ice on the blades. Thanks to these intelligent systems, the nacelle can automatically rotate to always face the direction of the wind, maximizing energy production. Each blade can also adjust its angle independently. When the wind is weak, the blades move into a position designed to capture even the smallest current of air. But when the wind becomes too strong, they change angle to reduce the load and prevent structural damage. Because even though it may sound contradictory, too much wind can also be a problem. A wind turbine does not operate endlessly at any wind speed. Normally, it begins producing electricity when the wind reaches between 6 and 9 miles per hour. Its performance then increases progressively until it reaches maximum power, usually between 28 and 34 miles per hour. But if the wind exceeds speeds close to 56 miles per hour, the safety systems activate and completely stop the machine to protect it. The real danger happens when the emergency braking system fails during a storm. In that situation, the blades can spin so fast that the aerodynamic loads and centrifugal forces exceed the structural design limits. A blade whose tips normally move at around 185 miles per hour could reach much higher speeds. At those speeds, even a small crack or structural defect could spread rapidly and cause the structure to collapse. But the electricity produced by the generator is still not ready to reach our homes. Even though it has already been created by the rotation of the gigantic blades, it still has to pass through a series of electronic systems that prepare it for its long journey through the electrical grid. The first step is passing through power converters. These sophisticated systems act like true electrical translators. Their mission is to adapt the frequency and voltage of the electricity being generated so that it matches the exact requirements of the grid. Without them, the energy produced by the turbine would be too variable to safely integrate into the electrical system. After that, the current reaches one of the most important components in the entire installation, the transformer. Although it may look like a simple electrical device, its function is essential. Electricity leaves the generator at a relatively low voltage, usually a few hundred volts. If we tried to transport it that way across dozens or hundreds of miles, a large part of the energy would be lost as heat. To prevent this, the transformer dramatically increases the voltage. By increasing the voltage and reducing the current, energy losses are greatly reduced. The difference can be dramatic. A turbine may generate electricity at a few hundred volts, but after passing through several transformers, that same energy can travel through high-voltage power lines at 220,000 volts, or even more than 400,000 volts. Once transformed, the electricity leaves the wind farm and begins a journey that can stretch for hundreds of miles. During this journey, the energy passes through different electrical substations where the voltage is gradually adjusted. First, it is reduced for regional transport. Then it is reduced again for urban distribution. And finally, it reaches the standard household voltage used by the outlets in our homes. The most surprising part is that this entire process happens almost at the speed of light. From the instant a gust of wind makes the blades of a turbine spin, the energy can enter the electrical grid almost instantly and become available to power lights, appliances, or factories located hundreds of miles away. So the next time you see a wind turbine turning slowly on the horizon, remember that what looks like a simple spinning machine is actually one of the most advanced energy systems on the planet. It is a giant structure that captures invisible wind, converts it into mechanical force, transforms that force into electricity, and sends it across the grid to power the modern world. And all of it begins with something as simple and as powerful as moving air. Give this video a like if you enjoyed it, and share it with someone who might find it interesting. And make sure to subscribe to this channel and turn on notifications to keep learning. See you next time!